Hi guys, hi, good evening everyone. So welcome to day 3 of Master Data Structures and Algorithms. Welcome back guys, welcome back. And this is day 3. So we were discussing a lot of important stuffs in data structure and algorithm. So the last thing we discussed was linked list. We have not yet basically seen the code implementation of linked list, which we will do right now, right away. But yeah, that's what. For a quick recap, we had discussed linked list actually to all of us. We have discussed. We started linked list intro, and today we are going to see how basically linked list is implemented. Apart from that, I have also planned to do some other stuffs also, like greedy and all. So we'll also do that. So hi everyone, let's see who all are there today in the comment section. Hi Hemant, hi Amrita, hi Ankit, hi Jigar, hi Shaurabh, hi Suraj, hi Sai, hi Ankit again, hi, good evening. Yep, yes, we also discussed pointers. We discussed pointers, dynamic memory allocation, and we discussed we had introduction to linked list. We have not yet completed that. So let's continue from that point. Okay, right? I'll share you. Just give me a moment, guys. Sharing a screen with you all. Basically, that same good old whiteboard. It's taking time to initialize actually, so it will take time. So where we were guys, basically we were discussing that creation of node, right? We had a self-referential structure, and we created two node. Basically we created pointer to structure, and then we allocated memory, right? And then using that pointer we stored value in those two node, and finally the last step what we did is we linked them together. That's what we did, right? So as I said already, I would be giving a quick recap of that, and then we will start implementing that code of linked list. Just give me a moment, it is taking a bit more time today. I'm not sure why. Yeah, yes, Dharmik, yes. I'll give you a quick recap of the thing which we started yesterday. Yeah, can you all please confirm, is the video clear? I think it's clear to me. It's fine. Okay, so now finally I'm sharing a screen with you. Okay, is it visible, guys? I've shared a screen. Please confirm once. Is it visible to you all? Yep, I think it's now visible to you, everyone. Okay, fine. So yeah, this is what we were discussing, guys. We were discussing this all things, like creating node and self-referential structure, creating and all. So what I'll do is I'll clear this code right now in front of you, and we would basically discuss once again that part. Let's see. So let me clear this entire stuff here. Okay, see this. So what I had, we had a self-referential structure first of all, right? So let's try. Let's write that struct node. We had a data part and we had a link part. So that link is nothing but node star next, right? This is it. And what we did, we tried to create two node, but we have to use dynamic memory allocation here, because linked list is supposed to be dynamic. So we should not create structure object through static memory allocation. Rather, we take pointer to the structure and create memory or allocate memory dynamically. So let's do that. So first of all, I would create one node. So I'll write here node star, let's say x equal to new node, new node. So this statement will allocate a memory for one node. Okay, right? It will have this data part and this next part, two parts, right? One node has two part. One is data part and another is next part. Then what is the next thing? So basically this new node will allocate a memory and that will return the address of the new node, which will be stored in x. So x here is a pointer which will hold the address of the new node. Let's say address of new node is 101. So this x will hold 101 and it is pointing to the new node. How do we store value in this node using this pointer? So guys, you access members of structure using pointer through arrow operator. If you have structure object, then you use dot operator. But if you have pointer to the structure, then you use arrow operator. If I want to store 20 here in this data part and null in the next part, I need to write here x arrow data, let's say equal to 10. So 10 would be stored here. And if I write x of next equal to null, so here null would be stored. That's how it works. Okay, this is what is done, guys, here. So 10 is stored in the data part, null is stored in the next part. Okay, right? Then I'll create one more node, y, node star y equal to new node. Let's say I'm creating one more node. Let's say I'm creating one more node, because the whole point here, guys, I want to create two nodes and link them together, right? This is the very first thing, initial part of linked list, because in linked list it's a collection of nodes which are linked together. So here I'm just showing you a part of it, just creating two nodes and linking them together. Okay, let's try to understand how to deal with the structure members, how to access them, how to link two nodes. Then we'll talk about how exactly to form the entire linked list. Okay, fine. So whenever you write this node star y equal to new node, another node is created. It would also have this data part and this next part, right? And let's say address of it, let's say it is 201. So this would be stored in this pointer y. Okay, right? Y would hold address of this new node. So y is basically pointing to the new node. That's the exact thing. Same thing, whatever we did with x, same thing is being done with y. So y is now pointing to the new node and it is holding address of the new node, that is 201. So same thing, guys, if you want to store something in this data, if you want to store here something or here something, so you need to access it that way, right? Y of data, in y of data you want to store 20, let's say. So 20 would be stored here. Then y of next equal to null. So here null would be stored. Okay. Now how to link them together? I want to link them together. How to link this? So linking basically means next of this X pointer should point to this new node. Okay. Next of X should point to the new node. So basically you have to change the value of X of next. In X of next, if you store Y, what is Y? Y is 201. Value of I is 201, which happens to be address of the new node. So if you store 201 here, this null would be now replaced with 201, and this next is pointing to this new node. So this is how you create two node and link them together. Okay, understood guys, how to access members of the structure through pointer and how to link two nodes. Is it clear? Because right now I'm getting into a code part, so I'll open this code blocks meanwhile, and we'll start coding this linked list. Okay. Is it clear up to this point? If you have not registered for the course, then the link might not be working. You just have to register for the course first, guys. Maybe reload it once. First you try to reload if it is not showing up anything, or you just log in. If you are not logged into the system, the portal, it might show you 404. So in that case you can log in. Okay, fine. So this is what we had discussed already. This was a recap of that thing, guys. Let's now jump into coding part. So let's start the coding this linked list thing. While coding, we'll also discuss some more concept actually. But right now, that's what I'm going to do. I'm starting the code part. So let's share code blocks. Code blocks here. I hope it is visible to everyone. This code blocks, guys. Yep, it is visible. So I'll create a new file here, and let me name it as okay, it is taking some time. Linked list dot cpp. So first thing first, I have to include the header files and all the classes, actually iostream class and all. So hash include iostream using namespace, right? Okay, then int main, and just complete the template here using namespace std. So what is this? iostream is a class, guys, input output stream class. This is what you need to include to so as to use the C out and C in on other stuffs, right? Okay. Yeah. Now, so see these guys. So we will talk about various operations here. Various operations like insert and operation of the linked list we'll discuss. Right. Okay. So node star insert and operation we'll discuss. We'll take an element here, let's say. Okay, right. Then we will also discuss other stuffs like display and all. But first of all, let's focus on this insert and operation. So insert and operation means, guys, you create a node and insert at the end of the linked list. Let's say there are some nodes in the linked list, right? So you create a node and at the like add it towards the end of the linked list. That's it. Okay, right? So create a linked list. uh, we are about to create linked list, but first of all, let's actually understand this insert and operation. What insert and operation does, insert and what it will do, it is saying insert a new node at the end of the linked list. So basically you will create a new node and insert that node at the end of the list, end of the linked list. So anyway, you have to create a new node, guys. Not only this, like if you call insert end operation 5 times, then you have to create new node 5 times. Not only this, insert end, if you go for insert beginning or insert after a node, okay, right? In every case, every insert operation, you have to create a node and insert it at the saved place. Okay, insert at the saved place. So how will we insert and all those stuff we'll discuss. So first of all, we are talking about here insert a node at the end of the linked list. So basically we'll create a node, and to create a node we need that structure, right? Self-referential structure. So let's first discuss that or write that self-referential structure here. So struct node int data, then we have the next part, right? Okay, this is the structure we have. So to create node, I need to create pointer of this, like I need to create memory dynamical. That's it. So basically, guys, it's not only one time I need to create a node. Insert function might be called many times. Not only this insert at end, maybe insert at beginning or insert after a node might be called many times. So for that, I'll not create this node star new equal to new node or node star temp equal to new node. I'll not write it every time. I'll not execute that every time. What I'll do, I'll write a function create, whose task is to create a new node and give me the address of the new node. Understood, guys? What I'm saying? See, what happens here is, what I'm trying to say is, if I define this insert end, okay, right? If I define this insert end, my point is, so you want to create a new node, right? So you will write here node np equal to new node x. X is nothing but data of the node you want to store. X is the data of the node, and then you will write np of next equal to null. Here you cannot write x actually, just write new node. Okay, right? So np of next you have to store null, and np of data, in data you store this x. This is what you have to write. Okay, every time this would be executed here. This thing you have to write. Got it, guys? Are you following? So insert end operation, it would be done. Let's say you have one more insert operation, insert at beginning. Even there you have to write this, because anyway, if it is insert operation, then you have to create a node anyway, because either you have to add it at the end, either you have to add it in the beginning, or let's say you have to add somewhere in the middle. Anywhere you need to create a node and then you add at the respective place. So why to write this step every time in every insert function? How about creating or writing a function which will create a node for us? Whenever you need to create a node, just call that function that will create a node for you and will return you address of that node. That's what we will do, right? So let's start this. Let's write this create node. So node star create. So it's same thing, guys. It will take the data for the node. Okay, I'll define it right away. So create node function, task of this function is to create a node and return us address of that node. That's it. So let's define it. So here we'll write node nptr. This would be obviously pointer equal to new node, right? So nptr of data equal to, that's sent argument x, and nptr of next. We don't know what is the next node right now, so we just store null in the next part. And what you have to do is you have to return address of this node. So just write nptr. When you write return nptr, what is nptr, guys? Nptr is pointing to the new node. Basically nptr is holding address of the new node. So when you write return nptr, you are actually returning address of the new node. Okay, so whenever you want a new node, let's say I want here Obviously this is insert end function, so I want to create node first, and that node I need to insert at the end. So whenever you want to create a node, so what you can do is you can just call this create function by passing the data of the node. That's it. Whenever and wherever, if you want to create a node, just call this create function by passing data of the node. X is the data of the node. So your node is created. Now the task is to add it. Okay, now the task is to add it to the linked list, guys. How to add in the linked list? There are certain scenarios for which I would like to go back to our good old friend whiteboard. I'll be explaining there what are the different scenarios and what are the different situations there. So let's talk about that. See, guys, first of all, when you are trying to insert a new node to the linked list, it might happen that there are no node at the linked list. There are no node in the linked list. Let's say linked list is empty. This is one situation. Let's consider that. Okay, right? So what exactly happens in linked list, guys? See, this is a linked list. Okay, this is a linked list, and there is a head pointer which always point to this first node. We call it as head node. Let's say first node address is 101, second node address is 201, similarly this is 301, this is 401. So this head will always store 101. It will always point to the first node. We call it as head node. And guys, linked list starts from the head node. We consider that head node is the first node of the linked list. That is the entry point of a linked list. That is where you start the operation. Okay, right? So linked list elements start from, or the nodes of the linked list starts from the head node. Head is a pointer which is always pointing to the first node of the linked list. So this is what happens in the linked list. So if I'm saying now linked list also can be empty, because this is the very first time you are calling the insert function, the linked list might not have been created yet. In that case, linked list is empty. And when linked list is empty, guys, this head value is null. Okay, it is not pointing to anyone. That means there are no node at all in the linked list. Head is null. Head is null. That means the linked list is empty. So while discussing this insert operation, insert at end, see guys, there are two scenarios. One scenario, first scenario is the linked list might be empty. There might not be any node at all in the linked list, right? Okay. Second, there might be already some nodes in the linked list. You just have to add the new node at the end of those nodes. Two scenarios. Two scenarios is what we have to check about. Let's first discuss about this head equal to null condition. That means let's discuss about if the linked list is empty, how to insert a new node. So guys, in very simple language, I want to say here, if you want to insert a node, it may be at the end, it may be at the beginning, or wherever. But if the linked list is empty, that means you are about to insert the very first node of the linked list, right? You are about to insert the very first node of the linked list, right? So check that situation first. You'll write if head is equal to null. If head is null, that means if linked list is empty, then what to do? That's what the question is. I'll explain. If head equal to null, then what to do? Anyway, guys, already you might have created the new node by calling the create function by passing x. Already you have the new node, because this is insert operation. Whatever happens, anyway, you will add a node there. Okay, there is no concept of like memory is full or something here. No, memory is there. It is dynamic memory allocation. So you will allocate memory dynamically and add it to the linked list. So you have already created a node. Let's say that node is this. Okay, maybe data is 10 and it is null, let's say, and address is, let's say, 101. So this is pointed by this np. This is what will happen after this statement. Now you are checking if head is equal to null. That means if the linked list is empty, then the current, this new node should be the first node. You are about to insert the very first node of the linked list, so this node should be the first node, right? Okay. So what you have to do in that case, what you just have to do, just have to make head point to this node, and store here 101. That's it. So if head is equal to null, you just write head equal to np, so that the new node should become head node. Head node should be pointing to the first node. The new node is the very first node. You have changed the head value. Now head is pointing to the new node. You say you have successfully added one node to the linked list, first node to the linked list. Linked list has been created. Did you follow this or not, guys? This step. Tell me. Let me know. Did you follow this step? We are talking about the first scenario where head is null, or that means if the linked list is empty, then you are about to add, you are about to insert the very first node in the linked list. And this is how you do it. You check if head is null, that means the linked list is empty. So you make head point to the new node, and your task is done, because this is the very first node. So head should point to this node. This is called head node now. This point is clear, all of you? Clear, right? Okay. So this is how you insert a node at the end when linked list is empty. See, guys, when linked list is empty, it doesn't matter when if you are inserting at the beginning or you are inserting at the end. That would be the first node, and head should point it. That's it. Then the second part is, or second scenario is, let's say there is already some nodes in the linked list, and you have now created a new node, obviously. So you have created a new node. Let's say the datas are 5, 10, 15, 20, and this is a new node which contains 25 and null. Address of this, let's say 501. So there is a pointer np which is holding address 501. Okay, right? See this. We are talking about insert at end, right? We're talking about insert at end. So how to insert at end here? How would we able to insert at end? Insert at end would only be possible if we can make a link, if we can form a link here. The next of last node should point to the new node. Only then we can say yes, we have successfully added a node at the end of the linked list, right? Okay, then only we can say yes, we have successfully added a node at the link at the end of the linked list. So basically I should be able to access this node, so that let's say temp or t, some t is pointing to this node. Then I can happily write t of next. In t of next I can store np. What is np? 501. In t of next, if I store 501, then this link would be formed, and I can say yes, I have successfully added a new node at the end of the linked list. But the point here is how to make t point at this node, at the last node. That is the whole thing here which we need to tackle. So let's clear it out first of all. So there is like 501 is not yet stored there. It is still holding null. I need to bring this t here. How can I make it? How can I bring this t here? See, guys, it's again very easy. You just have to take a pointer. Okay, anyway, I've already told, guys, you can enter a linked list from head node. Head node is the starting point, no other way. You start from head node and you go till the end. You have to traverse, as Hemant, I guess, is saying. Yes, exactly, you're correct, Hemant. You start from the head node and you traverse till the last node. When you reach the last node, stop there. Then you can perform this step. Okay, when you reach the last node, then you can perform this step. That's what. Okay, so let's write the code for it. So in order to do that, what you have to do is you have to take a pointer, let's say temp or t, and you have to make it point to the head node. So t is a head pointer which is pointing to the head node. Let's say it is storing 101. See, head is stored in t. Head is 101, t is also 101. So t is pointing to the first node. So you need to shift it right till the end. How to shift it? It is very easy. You just write t equal to t of next. Okay, you store address of next node in t, so t would be pointing to the next node. That's it, nothing else. And this is a repetitive process. Till the end you have to go, like till the end you have to traverse, you have to iterate over the linked list. You have to start from the first node and you have to go till last node. So basically we will write this statement inside a loop. Okay, right? what should be the condition? Somewhere you should stop, right? You should stop here. So T, see this. T here is pointing to this. So I need to shift this T this way, and I should stop here. When T would reach the last node, I should stop here. That's the thing here. So what should be the condition? Till what condition is true? Like till what point this T should be shifted? Till what point this T should be shifted? You can simply say while T of next, while T of next. You can write T of next not equal to null. You can also write only T of next. See guys, till T of next is valid, this loop will run and T will be shifted. See this. Now, T is 101, right? I'll write some values for you. So here this 201 is stored, here this 301 is stored, here this 401 is stored, and here it is null. Fine. While T of next is T of next is valid. Yes, T of next is 201. It is valid. So T would be shifted. Okay, right? See this. So T is here. T of next is 201, which is valid. So T would be shifted. Now T is pointing here. Okay, right. Now T of next. T of next is 301, which is valid. So T would be shifted. T of next, which is 401, it is again valid. So it would be shifted. Now T of next is null, which is invalid. So the loop will stop here. So when you come out of the loop, T would be pointing to the very last node. So you just have to write this statement. In T of next, you store NP. So this would be updated at as 501 and this would point to the new node. That's it guys. You have successfully added a node at the end of the linked list. That's it. Okay, right? You can write T of next not equal to null, or you can just write T of next. It means the same. Similarly here guys, you write if head equal to null, or you can just write if not of head. Not of head. See, when head is a valid address, not of valid address would be false. When head value would be null, not of null would be true. So if the condition would be true, then head value is null. So you can write head equal to null, or you can just write if not of head. Similarly here you can write T of next not equal to null, or you can just write T of next. When T of next will become null, this condition would be automatically false. Okay, clear guys? Okay, right. So I have taken a T pointer. T is pointing to the first node, head node, and I'm continuously shifting this T till it reaches the last node. So that's what this loop is for. So T is first of all pointing to the first node, head node. Then I'm shifting T till this condition is false. Till you reach T of next as null, this T would be shifted. Okay, right? So T is first of all pointing to the head node. T of next is 201. It is valid. Condition is true. Shift T. Now T of next is 301. It is valid. Shift T. Now T of next is 401. It is valid. True. Shift T. T of next will be null. Now the condition is false. So you'll come out of the loop. When you are out of the loop, where T is pointing? T is pointing to the very last node. So you just have to store the address of new node in the next of last node. That's it. That is this statement is doing that. You are storing the address of new node in next of last node. That's it. Finally, it is done. So this is how you insert a node at the end, guys. This is how you insert at the at the end of a node. One simple thing I need to discuss here. Okay, there is a important point which I need to discuss. See this. Whatever I discuss here, guys, let me write it down as a function concept here. Actually, we have already discussed. Let's write it as a function concept. So it is insert beginning, right? So it will obviously need the head node address. Obviously, it will need head node address. Otherwise, how will it fetch the linked list? Linked list starts from head node. Head node is the entry point to any linked list, right? You start from head node. Then you need the data of the new node that you want to insert. So you create, first of all, you create that node, the new node, np equal to new node. Oh, sorry, my bad. We just call the create function, which will create the node. We don't have to write this new node and all. just call the create function by passing x. It will create a node and it will return the address which will be stored in np. So np basically is pointing to the new node. So next, what you are checking? You are checking is if head is null. If head is null, then you are storing head equal to, you are storing the address of new node in head. That's what you are doing. Okay. Then what is the next thing? Next thing you are doing is, if head is not null, then that means there is at least one node or two node or maybe more than that, but at least there is one node. So in that case, what you are doing is you are taking a temporary pointer which is starting from head node, then till you reach the last node, you are shifting the shifting t, so that when you are out of this loop, sorry, so that when you are out of this loop, you this t would be pointing to the last node, and after that you can easily store address of the new node in the next of last node. So basically this is what you are doing, trying to do. This is the entire code. But there is a catch here, guys. There's a catch. What is that catch? Let me show you this. Okay, let me show you this. I think I should go back to this code and I'll show you where is the catch, where we need to be very careful. See, now let's go to this main function. Where is the main function? Yeah. So see this. So initially I will create head. Initially, obviously, it would be null because there is no linked list at all. And I might want to insert a node at the end, maybe data for that is 10. Let's say I want to create a node with value 10 and I want to insert that at the end. The thing is, guys, this is the first node. Head is null, so this should be the first node. Right? This would be the first node to be inserted. My point here is, whenever we are in insert node, let me write that code here. The entire code, whatever we have discussed there, let's write it here. So here we'll write if not head, then what we'll do, we will do here head, we'll do here head equal to np, right? Otherwise, what we do, guys, we take a temporary pointer p which starts from head node and it will traverse till the last node. That's what we are doing. T equal to t of next. Okay, right? And finally, what we are doing in t of next, we would be storing the address of the new node. That's what we are doing. And we say, yes, our function is complete. This insert node at the end, it is complete. But there's a catch. It is not complete. See, guys, my question is, when you store np in head, is the original head that is in main function getting changed? Because the main function head, that is the original head, which is actually maintained in the linked list. In this function insert end, we have done here, whatever we have done here, we have stored np in head here. Okay, we have stored np in head here. But is the original head that is in main function, the main head, which is actually maintaining the linked list, is it getting changed or not? That is my question. Is it getting changed? So there are two heads, guys. Okay, see, there is a head in main function, which is local in main function, so initially which is null, and there is also a head. Okay, there's also a head locally in insert beginning function. There are two heads. So when you store np in head, basically you are storing np in the local head, guys. So if this is a new pointer, a new node, maybe 10, and this is null, and address is, let's say, 101, and this is np, let's say, and it is holding 101, it is pointing here. If this is the case, when you store np in head, this 101 would be stored in this local head, and this is pointing here. Okay, right? As soon as you come out of the function insert beginning, this would be deleted automatically. So the original head is not updated at all. When you go back to main function and check, this head would still be null. That means there is no added, like no node added, which is wrong. You have already, you added actually, you have done the insert beginning operation. You have added a node, but the most important part you missed out is updating the original head that is actually maintaining the linked list that is in main function. So whenever we are storing head, okay, whenever we are storing np in head here, whenever we are storing np in head, actually the local head is getting updated, not the original head in main function. So we need to do that. That is what we need to take care. So one addition here, what, see, it's very easy. How can you update that original head also? It's very easy. What to do is you change, like you assign np to head and you just return the new head. That's why, guys, I have also kept the return type as node star, because it is supposed to return an address. So you return the updated value to head. So in main function, when you call this insert beginning operation by passing head and the data, you should assign it to head. This insert beginning function should return you the updated value of head. That should be stored in the original head in main function. So what will happen is, guys, when you will come out of this what will happen here, when you come out of this insert beginning function, this insert beginning function will return you address of the updated head. So your original head of main function will also get updated. That means your linked list is updated, right? Because this head, when you come out of this function insert beginning, this head would be deleted automatically because this is local in that, right? Understood? Okay, understood this, guys. So now next thing, uh, let me tell you guys what I try to explain here is basically there are two kinds of head, two head here. One is in main function, one is local in main function, and one is local in insert beginning function. In main function we had a head. Also there is this parameter head here in the insert beginning function. So this head is local in insert beginning function, and there is one more head which is local in main function, and that is the main head, original head, which is maintaining the entire linked list. So when you store np in this head, the original head in main function is not getting updated. So what we did is we return the current value of head that would be assigned to the original head in main function. So remember this, when you call this insert beginning operation, this is how you should call: head equal to insert beginning head comma 10, right? And that's why it should have a return type node star, because it is returning an address of a node, right? So if it is return type is node star, so let's say, guys, this head not of head condition is false, so obviously it will come to this part, so it will do all this task, so it must return something, right? So even here you just write return head. Okay, even here you just write here return head. Even if the head value is not getting updated here, just return head. What will happen? The same value will get updated in the main function head. Okay, like what I'm saying is, let's say originally already there were two nodes in the linked list, 101, 201. So there are two head, main head, which is pointing to this, and there is this insert beginning function head, which is also pointing to this. We are in the function now. So now you are adding a new node. So new node would be added at the end, right? So this would point here. There would be no change in head. So you just return head, the same value would get returned. Okay, maybe it is 101, it is also 101. So you are just returning 101, same 101, which would be stored again in the h of main function. So there is no problem at all. Here there is no problem at all. So that's the whole process here. Okay, this is how you write insert beginning code, guys. So let's get back to the code ground here, this code blocks which I'm using, and let's complete this function. Understood, guys? Please let me know. Is it clear to you all? The concept of two heads, actually local, one head that is local in main function, okay, here, and one head that is local in this insert function, this parameter. So when I change this np, when I change this head here, basically I'm changing this head, this local head. Okay, it is not changing the original head that is in main function. So we need to return it. That's what I'm trying to say here. Whenever you change head, you return on that. Okay, that's why the return type is node star here. And as the return type is node star, so we must also return something here. So in this case, you can return the same head. There would be no effect. There would be no problem. Same value would be reassigned to the original head. So that in turns makes, whenever you are calling this insert end function, you should store it in head. So insert end function will return address of the updated head that should be stored in the original given head. This is how this insert at end works, guys. This is the whole concept behind insert at end operation. But how do we check it, cross check it, whether it is working fine, whether it is whether there is any mistake, or is it completely fine and all. So let's write the display function. Let's display the linked list. With that, we would be able to actually verify whether our code is working fine or not, because I might want to add some other nodes also, right? Maybe I might want to add 20, I might add 30, and I might add 40. But how do I cross check whether it is working fine or not? How do I cross check this, guys, whether it is working or not? I have to display the entire list to check yes. If the linked list, if it would if it will display 10, 20, 30, 40 the linked list element, then I'll be sure that yes, linked list has been created and I'm able to insert all these elements 10, 20, 30, 40 at the end of the linked list. Right, first 10 should be added to the linked list, then it should be 20, then it should be 30, then it should be 40. So this would be the output here. So let's write the display function very quickly, and let's print the linked list, and we'll get to know what we will get here. Like, what will be the output here? Is insert at end function is correct or not? Let's verify it. So for that, I would write a prototype first of all for display. We know we don't need here any nodes. We won't basically return anything. It is just a display. But anyway, we will need the head node address, because head node is where the linked list starts from. We'll start traversing from head node till the end. Okay, let's define this display node. Okay, right. So void display node star head. So we'll start from head node, guys. So what we'll do here, first of all, you need to check whether there is any node at all or not. If there is no node in the linked list, obviously there nothing to display. So you just can give a message that there is no node to print. So that's what we will do here. So we'll write if not of head. This I have already explained, guys. What is not of head? Not of head basically means if head would be null, then not of null would be true. So that means the linked list is empty. So here, what we can do is we can say link list empty or no node to display. That up to you. That's up to you what you want to print here. No node to display. Okay, no node to display. Right. Okay, now the next thing is you just return from the function no node to display. You just given a message here no node to display, and you just return that from the function because nothing to do. Linked list is empty. There is nothing to display. Just return from the function. If head is not null, let's say if it is not null, if there is at least one node in the linked list, we must print it, right? Okay, so we have to traverse the entire linked list. How do we traverse? Same thing, guys. It's quite similar to this operation. We'll start from the first node. Will every time we'll go to like next node, next node, next node, and while traversing, we'll print data of each subsequent node. That's what we are trying to do here. So while, okay, this you will say what is the, what would be the condition, you will say me, guys. Okay, I'll just write here t equal to t of next, right? And also before shifting t to the next node, I think I have okay, I'll just Instead of t, I'll just use head, guys, because it won't matter if I change this head. It won't matter to the original head, right? This is a local head. If I change this head here, there will be no effect on the original head in main function. So I can just shift this head, not an issue. Before I shift this head, this temporary pointer to the next node, I should print the data actually. Okay, I should print the data like with this cout head data. I should print first of all. Then head should be shifted to the next node. So print current data, shift to the next node. Print current data, shift to the next node. Print current data, shift to the next node. And this should be done till you print all the element, like till you print data for all the nodes. That's what we have to do here, right? Okay, okay, right. This is what we have to do. So it's basically same thing, guys, what we did here, this while loop. Okay, if you want to have an explanation of this, let me go back to this whiteboard and see there. Okay, it's basically same thing what we have discussed already, but anyway, you want, let me explain this. See this. So you have a linked list already. There are nodes here, right? And there is a head node here. There is a main head also, which will not change, will not touch it. But this is a local head, guys. This display head, which I'll change. So now there are elements here. Let's say this is 10, this is 20, this is 30. All right. Okay. So addresses are 101, 201, and 301. So here you are storing 201, here you are storing 301, and here it is null, let's say. So what we are doing is we are printing head data. So first 10 would be, then you shift head equal to head of next. First data would be printed, so 10 would be printed, then this head would get shifted to here. Then again head of data would be printed, that is 20, 20 would be printed, then head would be shifted here, then 30 would be printed, then head would be shifted here. When you reach here, you are beyond the range of the linked list, guys. You are out of the bound here. So already you have covered all the linked list. This is where you stop. So this is a continuous process, this is a repetitive process. That's why it would be inside a loop. But what would be the condition, the what would be the termination condition here? When t is out of the like range of the list elements. So basically when t, you can write while t till t is valid. Or in this case, if you don't want to take t, that's what we have not taken actually, we have taken head. So you can just write while head. Head is pointing here first time, head is valid, yes. So print its data, shift head to the next node. Now head is here, head is valid, yes. So print its data, take head to the next node. Head is still valid, so print its data, that is 30, and take head to the next node. Take head to the next node. Now head is null, head would be null. Now this condition will be false, you will be out of the loop. So by the end of this loop, you will have printed all the elements of the linked list, guys. This is how it works. Okay, this is how it works. So that is what I have written here in the code. You can check it out. It's the same thing. Whatever I discussed, it's the same thing. Only thing is I added this condition. If head is not null, sorry, if head is null, then no node to display already because linked list is empty. Otherwise, we do this process. Okay, we start from the head node. We start from the head node until head is valid. We print current node data and then we shift head to the next node. That's what we are doing here. So let's call this display function also and whether we have done it correct or not. So display, and in display we need to pass the head node address. So let's compile this once, guys. Build and run. Okay, I think there is some mistake in the prototype. Yeah, node head. Now it seems perfect. Let me again, I've saved the code. Let me again compile it. like build and run, compile and execute I have created. Yeah, there's no error at all. And see guys, I'm getting the output 10, 20, 30, 40. That means I was able to successfully add node 10, then 20 after it, at the end, 30 at the end, 40 at the end. That's why we are getting 10, 20, 30, 40 as the output here. So I think you're not able to see the output screen. Let me show you that also. Just give me a moment. See this. Okay, see this. So we are getting 10, 20, 30, 40 guys. So we are able to add node at the end of the linked list. And we could verify by display function. By displaying the linked list, we are getting these elements. But that means we have added 10, 20, 30, 40. And this is insert at end operation, guys, which we discussed now. Okay. Is there any doubt on this part? Is there any doubt on this part, guys? Please let me know. Fine. Yeah, Minal, that's what I did. I explained the code on whiteboard. Same thing I've written here. Right. So that's what we have been doing here, guys. So we inserted this node. So let's go back to this insert at end operation. So first of all, we created a new node. Then we checked if head is null. Then you store new node address in the head, and you return the updated head address, because we also have to update the main head, the original head that's in main function. If head is not null, that means there are already some nodes in the linked list. So basically, we have to add the node at the end, insert the node at the end of the linked list. So what I'm doing, I'm taking a temporary pointer t, which is starting from head node, and I'm taking t to the last node by using this loop. Okay, when this loop will end, t would be pointing to the last node. So when this t is pointing to the last node, when I'm reaching to the last node, I'm storing np in the next of last node. Right, that's what I need to do, and it is done. So you just return head, because anyway you have to return address of the head node address, guys. So uh, so when you return head, in this case here, there will be no change in the main original head. It would basically, you are returning the same value, because you have not changed the head node. Head is still the same. You just added a new node at the end. That's it. So this is insert end operation. And what we did in display, first of all, you checked if head is null, then that means there is no node in the linked list. So you're just giving a message that there is no node to display, and you are returning from the function, as you don't have to do anything. The next thing is, we're checking if head is not null, that means there are some nodes in the linked list, or at least one node there is in the linked list. You just have to print the data of that node. So while till head is valid, you are printing the current node data. Head is pointing to the first node right now, so you're printing current node data. Then you are shifting head to the next node. Right, again, look, condition checked. If head is valid still, so it will print current node data, and take the head to the next node. So likewise, it will print current node data, and then it will get shifted to the next node. It will print current node data, then it will be shifted to the next node, so on. When you reach null, then this loop will stop. So basically, you would print after the display function is over, after this loop is over, actually you would have printed all the elements of the node. That's what is being done here, guys. Okay, clear? So this is all about this insert and display, guys. So I have a task for you. Assignment for today, you can take as delete at end. Okay, delete an element from the end of the linked list. You can take it as an assignment, actually. Delete an element from the end. Right, delete a node from end of the linked list. That's the assignment question for you right now. So I would like to move on to another concept. Let me clear this out. Let's do a greedy problem, guys. Let's do a greedy problem actually, right? Okay, let's do a greedy problem. So let's talk about famous, very famous and classic problem. Okay, I think I should show you that code. Give me a moment. I am showing that code to you. It's a hackering problem actually, guys. I want to do here in front of you. I'll not will not code it solve it, but I want to make you understand actually, right? How it works and all. So I'll quickly show you that. Yeah, this is it. So it's taking time to open. Yep. So this is what I want to discuss, guys. This is a greedy florist. This is greedy florist problem. It's a very popular greedy algorithm problem, which is there in the is there in the HackerRank. It is a HackerRank problem, and it is very good problem, very classic and common problem for a greedy algorithm. Let's talk about this. I hope you can see the problem actually. And I'm logged in. It seems I'm logged in into a different account, not the user account of mine in HackerRank. Fine, not an issue. Anyway, I'm getting the question, so that's fine. So you can all have a quick read. You can take a minute, guys, and you can have a quick read. I'll also give you the question in a summary, quick summary. I'll also, in short, I'll also tell you the question here. So the question here says there are a certain group of people, let's say some friends in a group, and they need to buy flowers. Okay, some certain number of flowers they need to buy, and there is this florist who is greedy. He's greedy about two things actually. He needs more customer. He needs that. Okay, I need more customer. Also, so yeah, that's what he needs, more customer, and he needs more profit. So for that purpose, what he is doing, what he is doing is, when a person comes for the first time, okay, a person who buys flower for the first time, he's actually selling it at the cost price, the original price. Okay, but if a person comes for the second time, then the florist will not sell it at the cost price, will sell it at a higher price actually, to have more profit. Got it? Okay, right? So that means if you need to buy two flowers, then you will not go alone. You will take your friend along with you, because if you buy two flower, then for the first flower you will buy it at the cost price, but for the second flower you have to pay more than its cost price. And how it is calculating the cost price? See this. It's actually calculating this way. You can see this, right? 0 plus 1 and 1 plus 1. So when you are buying first flower, it is calculating the amount in this way: number of flowers you have already bought, plus the number of flower you are buying now, that is 1 obviously. So 0 plus 1 into cost price of the flower. Okay, you can take this example, guys. See this. So here, as you can see here, c equal to 1 2 3 4. That means it is actually cost of 4 flowers. 1 2 3 4, cost of 4 flowers. And I think this example, okay, let's not take this example. I think you would get confused. Let's take this sample input. Yeah, this is good sample input. It would be easier for you to understand actually. Let's talk about this sample input, guys. So this 3 3, this first 3, it is actually the number of flowers you have to take, you have to buy. And this 3 is actually the number of person in the group. Three persons are in the group, and all of them or sorry, three persons are in the group, and we need three flowers have to be bought. So as per the question here, guys, each one, if each one will buy one flower, then it would be minimum cost. The problem is here is about minimum cost, guys. Greedy algorithm is always applied on optimization kind of problem: maximize profit, minimize cost. Okay, that is how greedy algorithm works. I'll give you a like brief idea about greedy algorithm, but yes, let's understand the problem statement before talking about the solution of this problem. We will also have a brief about this greedy algorithm, how it works and all. Simultaneously we will proceed towards solution. Let's first understand this greedy problem actually. Let's understand this problem right now. Okay, right? So here, what we are seeing here is total 3 flowers are required, and there are 3 person. As understood by the question, if one person buys all the three, okay, if one person buys all the 3 flowers, then cost price would be more. But the problem is to minimize the cost. Why the cost price would be more? If one person buys all the 3 flowers, let me actually go back to whiteboard. See here. So cost price of the flower what are 2, 5, and 6, right? And there are like 3 flowers we need, and there are 3 person. So that's a 3 person, A, B, and C. Let's say they decided only one person will buy all the flowers. So this person A is buying all the flower. For the first flower, price would be 0 plus 1 into 2. Okay. What is this 0? Number of flowers he has already bought, and the current number of flowers. He is taking one flower now into the cost price, original price. Very wise. When he goes for the second flower, actually what would happen when he goes for the second flower, already he has taken a flower, right? So now it would be 1 plus 1 into 5 into cost price, plus when he goes for the third flower, it would be like 2 flowers he has already taken, plus one more flower he is taking into the cost price, that is 6. What is the total price? 2 plus 10 plus 18. So here it is actually 32 something, I guess we are getting. Yeah, so 28, 30. We are getting the price as 30. Obviously, it is not minimum. But if all this person A, B, and C buys, like if they buy one flower each, then it would be the cost price would be 0 plus 1 into 2 plus 0 plus 1 into 5 plus 0 plus 1 into 6, because this flower is bought by a different person, this flower is bought by a different person, and this flower is bought by a different person. So whenever a person goes for the first time, he has to pay the original cost price. But the moment the person goes for the second flower, he has to pay more than the original cost price. This is the question. Okay, this is the question here that we are dealing with. That we are dealing with. Right? What is the cost price here now? The updated. So it is 2 plus 5 plus 6. That is 13, right? So 13 is the answer which we got here. Sample in the sample test case, we you might have seen their answer was 13. Yes, this is the minimized cost or minimum cost that this group has to pay to buy 3 flowers given this cost array. This is cost array, guys, because basically cost of the 3 flowers, 3 types of flower, that's it. Okay, right? Now if you go to the second sample test case, I remember it, so I'll just write it here. Second sample test case says they need 3 flowers. They need 3 flowers. Okay, but number of persons are 2, and cost array is same, 2, 5, and 6. Okay, right? They have to buy 3 flowers, but now the number of person is 2. If number of person is 2, obviously let's say A and B, then either A will take 2 flower and B will take 1 flower, or A will take 1 flower and B has to take 2 flower. Someone has to repeat, someone has to take an extra flower, because total 3 flowers need to be bought. Okay, total 3 flowers is to be bought. So either A will take 2 flowers or B will take 2 flowers. Right? Okay, that's what need to be considered here. Okay, fine. Now see this. Now, if let's say A is buying or B is buying 2 flowers, let's go with this. Let's okay. First A is buying the flower. Okay, A would buy the flower and then B will buy the flower. Okay, what would be the minimum cost and all? We'll come to this point. We'll come to this before I sorry. Before coming to this solution actually, before we discuss how to find the minimum cost here, we need to understand how greedy algorithm actually works. So guys, as I said already, greedy algorithm works on optimization problems like this: minimize the cost, maximize the profit, maximize the sales, kind of this way. So greedy is basically greedy about the solution. It always runs behind the solution. It is greedy about taking the best element. Okay, right? Let me give an example here. Okay, we are getting diverted a bit, but yes, we'll come back to it after we have an idea of greedy algorithm. See, there are, let's say, three items, guys: A, B, and C, right? Okay, let's say A price is 10, B price is 15, and C price is, let's say, 8. And the question here is find the minimum cost. Find the minimum cost to buy two items. You have to take two items, let's say. Find the minimum cost. So greedy, being greedy about the solution, greedy is greedy about the solution. It always runs behind the best element. Okay, current best element, next best element, next best element, right? Okay, and best element will differ problem to problem. Like in this case, this particular problem, guys, here the problem, you have to buy two items, and the problem statement is to minimize the cost. So for this case, best element is the item with the lowest price. So it will take C with price 8, then it will take A with price A. So total cost would be 18, which is the minimum. So greedy is always greedy about the solution, so it will always go for the best element. It is greedy about taking best element. Best element will be different for different problem. Okay, it is for this case we had three items. You had to take two items, and the problem statement was to minimize the cost. So as per greedy, it will always pick element with minimum cost, then the next minimum cost, then the next minimum cost. It will pick in that way. If let's say the problem statement is about maximize the profit, then it will select element that would give maximum profit first, then the next maximum profit giving element, then the next maximum profit giving element. This is the way in which greedy works, guys. So it is always greedy about the best element. It will always take greedy approach. It's a greedy approach, and always it will take the best element. A best element would be different for different purpose, different for different problems actually. Like for minimize the cost, it will take the item with minimum cost. For maximize the profit, it will take the item which will give maximum profit always, because it has to maximize the profit. Okay, right? So this is what this greedy does. So as per the discussion we have right now, as per the discussion we had right now, that greedy solution always runs behind the solution. It is greedy about the approach. Basically, you have you have to go to market. There is a long route. There's a main road which goes to long road, and there is a shortcut route. So greedy approach will make you go through the shortcut route. Okay, shortcut route. That's what greedy approach is all about. So as per the logic, as per this logic, guys, let's come back to this problem here. You here the problem statement is again same: minimize the cost. What would be the take flowers in such a way so that the cost would be minimum? You just have to print the minimum cost here, right? And we have discussed here that for minimization cost problem, it will take best element is the item with minimum cost. So as per that, it will pick first this two, right? And then it will pick first the flower with price 2 because it is the minimum cost, right? Then it will take the flower with the next minimum, that is the flower of price 5, right? Okay, so it will take 5, then it will take the next minimum. Obviously we just have one. What is it? What you will get, guys? 2 plus 10 plus 18, that is 30 is what you are getting actually. Oh, okay, I think I had done a mistake here. I think I have to rewrite it. Sorry, guys, my bad. It will not be 30 because we have two person and not one person. My bad. So if person A is taking first flower, so 0 plus 1 into 2, person B is taking first flower, and as per greedy will take the next best element, that is element with minimum price, next minimum price, that is 5. So 0 plus 1 into 5, because it's a new person taking this. Is A is taking here, taking this flower, and B is taking this flower. Next time either B or A will take the flower. Let's go with A. So when A is coming to buy the next flower, so it has to pay more. It has already taken a flower. So what is the cost price? 2 plus 5 plus 12, and the cost price here is 12 plus 19, right? 19 is what you are getting, but this 19 is not correct. This is wrong, guys. This 19 is wrong actually. This is not correct. Why wrong? Why not correct? See, the problem here is we understood the greedy approach. We understood that greedy approach is always looking forward, or it is running behind the best element. Okay, but we need to understand what is best element here. Fine, it is minimize the cost problem, but we need to understand, guys, every time the cost of the next time the cost of the object or the item is getting increased. Okay, every time the cost of the object is actually getting increased. So if I give you a problem statement here, let's say you have to buy two commodities. There's a commodity X and there's a commodity Y, let's say. Okay, price of X is 50 rupees, price of Y is 100 rupees, let's say. Okay, you have to buy these two commodities, but there's some condition. Okay, the condition is you can buy one commodity per day. Today you can buy either X or Y. You have to buy the next commodity next day. There is an added information that next day the prices would be hiked by 50%. Okay, that means next day price of X would be 75 and price of Y would be 150 rupees, because it is getting hiked by 50%, right? 50% hike next day. So now you can also this has been given, you can buy only one commodity per day. So today you buy one commodity, next day you have anyhow you have to buy the next commodity next day, right? But the next day price is increasing. So would you buy X today or Y today? If you want minimum cost, if you want to pay less, okay, if you want to pay less, then which one would you pick first? Which one would you pick first? Which one would you buy first? Commodity X or commodity Y? Which one would you buy today, guys? If you want minimum cost, if you want to pay less, which one would you go? Let's talk about both the cases. Let's say I'll buy X first. So today I'll buy X. So I'll pay 50 rupees for X, and next day I'll pay for Y. So that is 150 rupees. Total it is 200 rupees, right? But there's another person, let's say he buys this Y today, 100 rupees, and then he buy X tomorrow, that is 75 rupees, because next day price of X would be 75. So 175 rupees. See, this person is actually paying less than this, because this person is smart. He's greedy. He's greedy about minimizing the cost, but he understood actually what is the best element. See, guys, okay, it is high. It is the price is increasing next day by some amount, by some fraction, by some percentage. So obviously, the price which has highest like value, maximum price, increase in its price would be more compared to increase in price with the item with lower price, with less price. Obviously, increase would be more. Okay, so you should actually take the item with more price first, highest price first, then you should take the item with lower price next, because increase in price for the higher value item would be more as compared to increase in price in the lower value item next day. Okay, so this is the whole point here. You need to understand what is the best element here. So basically this two is not the best element, guys. Actually 6 is the best element. You should take the higher value thing first, so that later you can go for the lower value element, and increase on them would be less compared to increase in this 6. Obviously increase in 2 would be less compared to increase in 6, right? 2 into 6 is 12, but 2 into 2 is 4. See the difference. So best element here is not 2, guys. So A will buy first the flower of price 6, cost price 6. B will buy the flower with cost price 5, and then finally A will buy this flower with cost price 2. So you'll get 6 plus 5 plus this is 4. Total it is 15, which is correct answer. Answer will be 15, not 19. So you need to be clear with best element. What is the best element for this? Understood, guys? Everyone clear? Is this clear to you all? What is best element here? Best element is not the flower with less price, it is actually the flower with higher price. If you take flower with higher price now, then you don't have to pay more amount on that later when the price get increased. Okay, right? It's a simple maths. I have given an example of commodity in the real life example, so that's I think it should be enough to make you understand what we are doing right now here. Is it clear, guys? If you're done with this, basically we are done with the session, so we can call this a day and we can wrap this up. Clear? Done? Any queries, any doubt, guys, on this greedy florist problem? This is how you should approach. Okay, basically you have to arrange this array in descending order and not ascending order. You arrange the array in descending order and then you pick up 6 first, then 5, then 2 as per the formula, guys. Okay, number of flowers into the cost price. This is what you should do. Where x, what is x? X is the number of flower already taken by the person. Then this one is the like new flower plus one, and cost price of that flower, whatever, like 6 or 5 or 2. Okay, right? David, only thing is you have to sort it in descending order, not ascending order. Okay, you have to arrange it in descending order actually. Okay, because here you have to pick the flower with higher price first, then the flower with lower price. That is how you will have the best element first. Best element here is not the flower with less price, rather it is actually flower with the higher price, more price. You need to understand that. Clear, David? Yeah, yes, exactly, David. Whatever you say, it is correct actually. So you like you have to assign. You may maintain another array for person how many flowers that person has already taken. Okay, you might maintain according to that. You can calculate the price. Okay, according to that, you can calculate the price to be paid to the uh, florist. Clear, David? Is it clear or any doubt? Yeah, exactly. So then it is correct, David. Yeah. So it should be decreasing. Yes, it's fine. Okay, then, guys. So that's it for this data structure and algorithm session. So this is all about the like data structure and algorithm essential batch. So I hope you enjoyed all the sessions. Okay, I hope you learned something very important. I hope you understood. Now you have the clarity to create a linked list and all. So do work on the assignment, guys. That is delete a node from the end of the linked list. It is very much similar to the insert at end operation. You just have to use the delete operator to delete a node, to deallocate the dynamically allocated memory. That's what you need to understand. So okay, take that as an assignment, and you can also work this, guys. I'll not give this as an assignment. You work it out. You go to HackerRank page, just search greedy florist and try to solve the problem. I think you have now idea how it is like getting solved and all. So just go there and you solve the problem. Okay, so guys, that's it for this data structure and algorithm session. So thank you for attending, everyone. I really enjoyed the session. I hope you also enjoyed the session and you understood whatever we discussed. So let's meet some other time. Maybe we will cover some different topics in some different session of DSA, guys. Also we are coming up with some Java programming classes. Also, we are coming up with HTML, JavaScript. We are coming up with AWS. We are coming up with Tableau. We are coming up with machine learning. We are coming up with Python. Python and the data science related libraries of Python. So many upcoming programs are coming, and guys, just have a look, have a check on our website on and our Instagram profile. Also, guys, if you want to check our PGP full stack programs, you can also do check out. As I said already, it is a full packed program, 6 months long, which where we will start from the scratch and we'll go till the very in-depth discussion. You'll be an expert in that field, guys, and more on that. You'll be also prepared. You'll be also given a detailed discussion on data structure and algorithm, also system design concept, also cloud computing concept, also your interview preparation and all that would be guided to you. And yep, on the top of it, you would be getting placement. So companies will be coming and recruitment drives would happen. You would be placed through LetsUpgrade. All this thing at a very nominal price, affordable price. It is actually to 29,999. But if you enroll it before like 3 more days, then you will get it, like you can have it at 25,999. You can have a discount of 4,000 rupees, right? So do check out our PGP courses. Okay, I think links were shared already before some time. Why they even also repost the links of our PGP programs. You can check it out, guys. Okay. Also, guys, if you have any query, if you have any query related to any of our PGP course and you want to get it answered, it is not about enrolling, but if you want to get it answered, then you can also fill this form, luc.to/pgp. You book your time slot and we will reach out to you, like one of my team or anyone from my team will reach out to you and answer your queries. Okay, right? Certificate, Jisan, we will actually once you submit all the assignment, after your deadline is finished, we will review all your assignment. Okay, if you are eligible, if you are found eligible, then you would be contacted like via mail, or maybe you have to submit your addresses. Okay, right now we are working on a different system. It would automatically be collected in our system only. Let's upgrade in platform only. So we would then send the certificate over your address. You might have to update your address in our system, then we'll send this certificate to you. But we will need some time, guys, because we need to review the assignment and all. That will take some time, because it is not only assignment of one person or two person. We get lot of assignments, so we would need some time to review them, and then finally we'll uh, like release it out. For the participation, even you'll get it by mail, or you can just log into letsupgrade.in and you'll find the certificate section, guys, on the right top. In the profile section, there is a certificate section. You can also have there your certificate participation. I think also you'll get completion certificate there, but those who would be eligible for completion certificate, you'll also get a physical copy of it. Okay, that's it. So I hope now there's a clarity about the certificate. Also I think you can check out the our postgraduate programs links, guys, PGP links. You can check it out. Also, if you have any query, you can also fill this luc.to/pgp form, which I have pinned right now in the comment. So you can check out them. Right? Okay. So that's it, guys. That's it for this master data structure and algorithm class. Let's meet again some other DSA session. Maybe you can like I'll be taking Java session also. You can also be there, and you can also get enrolled in other programs also. And, you learn a lot of things. So that's it, guys. So yep, time's up and our things are also done. So bye bye, guys. Take care. Let's meet again sometime. So till then, guys, bye bye and take care. Keep learning and keep rocking.